Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat berjumpa dengan ICAS 2024. Here I will present my research. The title is Design of Auto-Ballast Piston Tank Static Type System on Remotely Operated Vehicle ROV using Fuzzy Logic Controller method. Abstract of this paper. We know that existing remotely operated vehicle or ROV ballast system often rely on manual methods such as attacking stones, which can be cumbersome and inefficient. This study introduced a novel automatic ballast system utilizing fuzzy logic control to improve ROV buoyancy and maneuverability. The system employs a static piston tank to regulate buoyancy driven by DC motors. GYPME 280 5-volt sensor measure water depth, providing real-time feedback to the fuzzy logic controller. An Arduino Mega 2560 S microcontroller connected to an ESP8266 and a joystick enables remote control of the ballast tank set point for efficient operation. Experimental results demonstrate the effectiveness of the system, with the ROV achieving an average floating height of 0 meter, diving depth of 95 centimeter, and sinking depth of 196 centimeter. The system also significantly reduced battery consumption compared to traditional thruster-based method, enhancing ROV endurance. This result highlights the potential of fuzzy logic-based control system in optimizing ROV performance and efficiency. As introduction, remotely operated vehicle or ROV is an underwater vehicle that is operated from above water surface to environmental conditions for exploration, investigation, or inspection. This is important perform as a substitute for human for underwater work for the sake of safety and urgency accuracy. ROVs have the ability to dive deeper than humans and capabilities maneuvering into a dangerous environment. Meanwhile, for static diving, that is by changing the specific gravity of the ship by means utilize a ballast tank as ballast and pump system to fill and discharge water from the ballast tank. The problem between diving time and power consumption time has a mutual correlation contrary to the practical function of ROV as an alternative to unmanned vehicles that have claimed efficiency across various capabilities. Therefore, a performance automation system is needed for the ROV ballasting system. Pay attention to the amount of power used for diving needs. Static auto-ballast system piston tank using the fuzzy logic controller method is a form of development that emerged problem with the ballast system applied to the ROV belonging to the Shipping Polytechnic Team Surabaya State. The main focus is the ability to control water circulation in the tank ballast. The system point use the command to flow, dive, and sink based on the application of Archimedes' law. Through this research, the result of application development, the ballasting system on the ROV will optimize the use of time and battery power observation and inspection. Method of this research is carried out at the boundaries of a problem that is a focus limitation of ballast movement tube method use and test set specification applied to the ability of the ballast tube to move, float, dive, and sink via the given point setting command. The second is use fuzzy logic controller Sukarno. Third, analysis was carried out on ballast tube diving in the Koni swimming pool, Surabaya. And fourth, the depth of water pressure in the swimming pool is 2 meters deep. The application of the use of sensor and actuator component is arranged as internal input and output research electrical schematic. Sensors are used to convert physical signal into electric signal can be processed by the system. Meanwhile, the actuator is used as a medium that can respond to signal control and produce physical action or change in the system. Here we use keyway sensor and also motor magnet. The result and discussion, we have two tables. Table 1 is thruster battery power use. Number 1 until 6, dive time in minute, 10 minutes until 60 minutes, and the remaining battery power 11.8 until 10.8, the thruster battery power use. Based on the result in the table 1, battery power use for 6 ROV thruster is 60 minutes is 1 milliampere hour. LiPo lithium polymer battery power can be measured in capacity units, namely mAh milliampere hour or WH watt hour. This capacity describes how much the energy that a battery can store and produce in 1 hour of use. Battery capacity is one of the key parameters that determine how long the battery can last use. Table 2 use of ballast tank battery power. The power used in the ballast tank is 3S LiPo battery. Use the initial battery power, charging before use, power using batteries with dive time record in table 2. The experiment result demonstrate the efficiency of the proposed automatic ballast system compared with the traditional one. However, the voltage drop was minimal, indicating that the ballast system operates efficiently without significantly impacting the overall battery life. In comparison to traditional ROV ballast systems that often rely on manual method or less efficient mechanical mechanism, the proposed system offers a significant advantage in terms of power consumption. The fuzzy logic controller and precision control in the ballast water level contribute the system efficiency energy. So the conclusion of this result is testing of the static piston tank ballast system for diving as ROV ballast on this research using fuzzy logic controller method. Piston and joystick pump function as circulation driver for the inflow and outflow of water into the tank ballast, move according to joystick point setting and water depth sensor reading. Output float depth 0, ballast volume 0, diving 0.95, ballast volume 7 to 5 liter, sink depth 1.68, ballast volume 1400 liter. Obtain the present error result of each condition: float 0%, dive 5%, and sink 2%. Meanwhile, the error percentage: volume output float 0, dive 7.2, and sink 0. So application of auto-ballast using the fuzzy logic control setting method is carried out by conversion fuzzy method program into Arduino IDE programming. Conversion result produced, the output is a volume of ballast water which has the same value when given the input pair of value. So this one is my presentation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.